Howdy folks, welcome to lesson 4 of the CompTIA Network Plus course. As you can see on the screen, today's topic is going to be the troubleshooting methodology. Now if you don't know what that is, in short, it's basically the troubleshooting steps one needs to follow when you need to go and troubleshoot your own problem or a user's problem. Now this could be computer related, can be obviously network related since we're doing a network course here. But it's in a nutshell, it's a bunch of steps. It's about 7 of them that you need to go and follow. A set of rules, I suppose, is what you can call them when it comes to troubleshooting. Now, before we go ahead and jump into today's topic, if you guys haven't done it already, you should know the drill by now. Please give the video a like. I do put a lot of effort into these videos. They do take a lot of time to create. And if you'd like to know when lesson 5 of this course comes out, maybe consider subscribing. Alright guys, now that we've got that out of the way, let's go learn something. Alright, so troubleshooting methodology. What is troubleshooting? Now guys, there's going to be times when you're going to get a problem. This is probably going to be from a user or a customer. They are going to report a problem, and there's certain steps you or a technician can follow to go and basically troubleshoot this problem, and at the end of the day, hopefully come to a solution to this problem and get it all working again. So what steps should be involved in troubleshooting? Now guys, I'm going to list them for you. There's about 7 troubleshooting steps. These steps are actually not just related to N+. You'll find these exact same steps in A+ as well. So the first one of these 7 steps is to identify the problem. Now I'll explain each of these individually in just a moment. So the first step is to actually identify what the heck the problem might be. Step 2 would be to establish a theory of probable cause. So how did we end up here with this problem? Why did the problem happen in the first place? Step 3, test the theory to determine cause. So at this point in time, you probably have a theory. Hopefully your theory is correct. Now you need to go and test that theory of yours to determine what the cause might be and to see if you're actually on the right track. If it turns out not to be that, then you're going to kind of have to start over with this whole list. Now, assuming your theory turns out to be correct, which it probably will most of the time due to your experience, then you need to go and establish what we call a plan of action. How are you going to solve this problem, whatever it might be, or this issue, whatever it might be? Once you've established a plan of action, then you need to go and implement that solution, whatever it might be. So you might need to go and repair something, you might need to go and replace something, you might need to go and change a setting or a configuration somewhere, so then you need to go and implement the solution, whatever it might be. Then you go and verify the solution. So even though you might have done this 20 years, you might have done this thousands of times, you always verify the solution. You never assume it's working, you verify. More on that later. And then lastly, guys, the last step here is to document all your findings, your actions, and the outcomes. You're basically going to go and document your findings, all the steps you took to go and troubleshoot the problem, even though some of them might not have worked. And then obviously, lastly, the outcomes of that. Did you actually manage to solve this problem or not? Is it working now or not? That kind of thing. Alright folks, so since we've got the list of 7 steps in front of us now, let's go discuss each and every one of these individually so you can get a better idea of what it actually entails. So starting with the first one there at the bottom left, that one would be to identify the problem. So with regards to identifying the problem, guys, there's many ways you can go about it. So I suppose there's certain variables we need to consider here. Is it the user that has logged this ticket? And do you have access to this user? In other words, are you able to ask them questions? That's actually a great way to identify the problem, is to ask the user questions. Now, unfortunately, there's going to be times when there is no user or the user is not nearby, which means you're going to have to go about it some other way. So you're going to have to gather information. This could potentially involve system information. So you may or may not need to go and check the specs of that computer. You may or may not need to go and check the specs of that server, the network appliance. This could be a network equipment. So if this is a switch, if this is a router, if this is a firewall, you might need to go and check the specs or the system information of that machine. And this can actually help you later down the line if you need to go to that vendor's website to go and get maybe some sort of help guide. There might be a frequently asked questions section on that vendor's website. Maybe there's other people that's experienced a similar issue. So it's actually quite useful to go and get information about this appliance if it happens to be an appliance. Other things you could potentially go and do to help you gather information would be to go and check any form of logs. This could be, but it's not limited to, things like an installation log, maintenance logs. If you're wondering why, it could be that maybe someone did some sort of installation somewhere, hardware or software wise, or maybe they changed something somewhere, hardware or software wise, and that could be the reason why there's a problem. Maybe someone made a boo-boo. It could be an honest mistake. It could be a compatibility issue. Maybe they accidentally broke something. The point is, if you go check the logs, it might give you an indication as to where to start looking. I'm not saying it's going to solve the problem, but it'll at least give you a lead to go on. And if you're lucky enough to have access to the users, like I said earlier, you can go and question the users. That's probably one of the best ways. So you can go and ask them open-ended questions to uncover information. So if you don't know what an open-ended question is, that's basically when you force the user to give you more than a one-word answer. It's not just going to be a yes or a no or a fixed answer. You're forcing the user, I don't mean that in a mean way, but you're forcing the user to give you more than a one-word answer. So you can maybe go and try something like asking them, in your opinion, when would you say the machine last worked? Or this component or this network last worked? Or have you by any chance recently installed any updates? Have you installed any software? Have you done any changes? Have you unplugged anything? Plugged something into the network? Anything like that. So ask them open-ended questions and basically just try to get them to give you more than a one-word answer. You can also try closed-ended questions, which I think you should know what that is by now, giving you a one-word answer. So the user is going to give you, or the customer is going to give you a one-word answer. I suppose the situation is going to dictate which one you want, but in my case, I'm normally a fan of the open-ended questions because I want to get them to give me as much information as possible. All right, folks, and that's pretty much all there is to it when it comes to identifying the problem. I suppose the main thing would be just to go and ask them questions and to try to guess more or less what the problem might be due to your experience. So I'm going to bring that list up here at the bottom again. So there is the 7 steps again. So we've covered the first one now, being identify the problem. Moving on to the second one there, establish a theory of probable cause. Now you're going to establish a theory based on the information you've gathered in the first stage. So you're going to establish a theory based on the findings during inspections, your findings when you went and digged in the system, specs or specifications or settings and stuff. You're going to base your theory based on the answers the user or the customer gave you. So yeah, I mean, depending on what you found when you did your investigation on that machine, that server, that network, whatever it might be, depending on that, or depending on the questions, or depending on both sometimes, that will lead you to establish a theory of sorts of what you think the problem might be. So if you look at identifying the problem, if we have to summarize the living heck out of this, imagine for a moment the user said the machine doesn't want to start. I mean, that's more A plus than N plus, but it's the same concept technically. So if the user says, my machine does not want to start, I mean, that on its own could literally be anything. The long list of things that could be is insane, folks. So by me asking them questions like, when last did your machine start? Or when last did your internet work, if it's a network related problem, anything like that, I can get a time frame, a timeline as to when this problem started. And if I happen to have access to some sort of logs or anything, I could potentially go and look in the logs in that time frame to see if I can see if anything changed, if the user happens to say that they didn't change anything from their side. So I can ask them, when did the problem start? What symptoms did you experience, if any? And that can kind of lead you to what the problem might be. So maybe they'll say, if this is a computer, by the way, or maybe this is a switch, they might say, my computer last started yesterday afternoon, but this morning doesn't want to start ever since we had that lightning storm last night. Or if it's a network related problem, they might say my network is working fine yesterday. Ever since that lightning storm last night, the network is dead. So you can probably see where I'm going with this. It's probably some sort of power surge. So if you look at step 2 there, establish a theory. My theory is a power surge occurred. Maybe the lightning struck something and there was a power surge and it blew something in their PC, if this is a PC related problem. Or if it's a network related problem, maybe something like a switch or something down the line got fried because of the power surge. So that is my theory. So I'm giving you guys two scenarios here at the same time. The one is a PC that doesn't want to start. The other one is a user that does not have access to the network or does not have access to the internet. So we're using kind of sort of the same scenario. Both of them is a power surge, but the one is a PC that does not want to start. The other one is an internet connection that's dead, basically, if you want to call it that. So my theory here is a power surge. It's not confirmed yet. It's just a theory. So now if we look at that list again, we've obviously done the first steps, 2 steps now. The third step there would be to test my theory. So if you look at the computer, if I suspect the computer has now been fried, it's probably going to be the power supply or the motherboard. Most likely the power supply unit has kicked the bucket because of a power surge. And the way I can test that theory is to put in a new or a working power supply that I know for a fact is brand new and that I know for a fact is still in a working condition. If the PC starts, then you know, theory confirmed, and you can move on to the next step. If it does not start, then, well, you need to move on to your next theory. If this is a network-related problem, if the user complains the internet is off or dead, and you suspect maybe it's the switch, if that's the only network component between them and the internet, or if you suspect it's the router or whatever it might be, change it of another one. Change it of another one, check if the other one solves the problem, or check if you can connect to the internet via another machine that's on the same network. If that works, then, well, you can kind of sort of rule out what the problem may be or may not be. All right, folks, so we've pretty much covered step 3 there in the list. So yeah, if you've tested the theory and you come to the conclusion, you know what, it looks like it might actually be what I initially thought it might be. So if it's a machine and it looks like it might actually be the power supply, or if it's a network and it looks like it might actually be the switch or the router, whatever you initially thought what the problem might be, if it turns out to be that, then you move on to step 4, which is to establish a plan of action. So we know what the problem is, but what are you or your company going to do about it? So in most cases, this involves, either repairing or replacing. That's generally what it's going to come down to. It's not the only thing, but it's usually going to come down to that. So if you look at something like a computer with a power supply, are you going to repair that or are you going to replace that? Sometimes the one will be more economical than the other. Sometimes the one will be safer than the other or quicker than the other. So if you look at something like a power supply, it's safer to replace it. It's quicker to replace it. It's cheaper to replace it. It's just a win-win-win all the way when it comes to replacing it. It's definitely not safe to repair those. It's not economical to repair those. And it takes quite a while to go and repair those. So generally, it's going to be easier to replace that. That is just an example. If you look at something like a switch or a router, is it worth it to go and repair it or to replace it if this is a network-related problem? You will have to be the judge of that. And obviously, you'll know what the component costs. Depending on what the component is, you'll know how long it's going to take to repair it, depending on what the component is and how much work it might actually be. So establish a plan of action. Are you going to repair, replace, or are you going to go and escalate? Maybe you know what the problem is, but it's outside your scope. You don't know how to do this, whatever needs to be done. Maybe it's a configuration. Maybe it's a setting that needs to take place, but you've got no idea how to go and do that. If that happens to be the case, then you might need to go and consider to go and escalate this to someone more senior that knows how to go and do it. Should you be lucky enough to have someone in your company that can do that for you. Right, now that we know establishing a plan of action is step 4, that's now after you've tested your theory, then you need to go and implement that solution. So with regards to implementing it, remember previously we said, are you going to replace or repair or go and configure or escalate? Now you need to go and implement those fixes. So this is the part where you actually go and repair this component or whatever it might be, if it is a situation that requires you to go and do a repair. Or this is the part where you go and replace this part or this component if it's something that needs to be replaced. Or where you go and do the actual configurations or the settings of what needs to actually take place. So this is where you actually go and implement what needs to be implemented. And if it happens to be outside of the scope of your knowledge or, maybe your expertise, then you can go and escalate to a higher authorization if needed. Sometimes it's outside your scope. You don't know how to do it or you don't know where to do it. Sometimes you're not allowed to go and do certain things depending on what the situation is. So if it's a small basic technician problem, chances are you are authorized. Other times you might not be allowed and you might need to escalate to someone higher that actually is authorized to go and do it. Even though you know how to do it, you might not be allowed to go and do it. All right, guys, so that will be step 5. Step 6 is to verify the solution. So after you've fixed it, like I said in the beginning of this video, don't assume it's working. You might tell me, hey, but I've been doing this for 20 years. Or I've done this 1,000 times. I know what I'm doing. I know it's going to work. I don't care if you think it's going to work. You still verify. Never assume. One day is one day and it's not going to work. Maybe you missed something because remember, we are human. There's always the human element to consider here. You can make a boo-boo. You made a typo. You made a small oopsie somewhere along the line. And then you're going to assume it's working and it's not. It's going to make you look like a fool. It's going to make you look unprofessional, especially if you're working for a company. It's not a situation you want to find yourself in. It can really backfire in your face. So guys, first of all, make sure the system seems to work for you according to what you think needs to work. And then after you verify that it works for you, then get the customer or get that user that this device or this appliance or whatever it belongs to, get them to come and verify as well. So if it's an internet connection, get them to verify that it's working for them. If it's a machine or a device or an appliance of some kind, get them to come and verify. Have them acknowledge that it's working. Now, what I want to add on to this is not really part of the course, this last one, but I actually want to add this onto this. It's just to help you guys out in the industry. This last step is not something that's part of the course, but it is something very important in the industry, is to make the customer agree and sign that it was working. I've had so many cases at companies where a user or a customer would say, yes, it's working. I agree it's working. And literally right afterwards, they would go and break it again in the same way they broke it initially. And then they want to blame you. They love blaming the IT guy. It's always the IT guy's fault, even though it's not your fault. If the lights doesn't want to work, it's your fault. If the paint on the wall doesn't want to dry, it's your fault. It's got nothing to do with you, but it's your fault just because you're IT. So what I'm going to encourage you guys to do, I wouldn't say it's a rule, but it's really going to help you out of a jam one day, is to make them sign. Make them sign and acknowledge that it was working, that you tested it with them. And then afterwards, when they want to turn around and say, no, but it's not working, you didn't fix it, you can go and yank out that piece of paper where they agreed that it was working. You can say, look here, you agreed that it was working. You went and fudged this thing up again. All right, folks, so that is basically step 6. The last step out of the 7 troubleshooting steps is to document your findings, your actions that you took, and what all the final outcomes was. So with regards to documenting your findings, that will basically be what was the initial problem. So when the user or the customer or your boss or whoever reported the problem, what was the initial problem? What did you find when you arrived there or when you started troubleshooting this problem? What was your initial findings? Then, what actions did you take? What steps did you take with regards to troubleshooting to try and solve this? You can, for example, mention there, I swapped this part, I swapped that part, I changed this setting, I changed that setting, did this, did that. You know, basically what actions you took. It doesn't matter whether the actions actually worked or not. It's just basically a breadcrumb trail to show us what actions was taken so that if something else happens down the line, you can always go and retrace your steps. Or if someone else wants to go and solve a similar problem later down the line somewhere else, they can go look through your little notes, so to speak, and they can see, okay, you know what? This guy did this. This guy did that. He says he had the same problem, and this is what he ended up doing. Let us go and replicate or copycat this guy. Hopefully, we'll get the same outcome. And then obviously, last part here is going to be the actual outcomes. What was the outcome? Did you actually manage to fix it? Did it actually work? Did it not work? I mean, you ended up working your butt off and it didn't actually work. What is the outcomes? And then the very last one I want to add here, which is not actually even part of the title, is to document any logs. If there happens to be any logs. There's probably not going to be any, but if there happens to be some sort of logs of any kind, server logs, firewall logs, whatever logs it might be, if you happen to have any, document them. All right, guys, before we conclude this lesson, so now we know what the 7 steps are. So you need to know what they are for the exam. And it's also important to remember in what order they need to go. The kind of questions you guys can expect in the exam about this, and there's going to be many questions about this in the exam, yes, is they will tell you user 1 has already done the following. They've done X, Y, and Z. What should user 1 do next in the troubleshooting methodology? So they might tell you the user has already identified the problem. They've already established the theory, and they've even tested their theory. They've confirmed that the theory is actually correct. What should user 1 do next? And you'll often see that the word next will be in capital letters in the exam, which means they want to draw your attention to that. So if you look at the little 7 steps at the bottom, if you look at the fact that they've already tested the theory and confirmed that it was working, the next step would have been to establish a plan of action. Now, I completely made that question up. I literally sucked it out of my thumb. But that's just to give you an idea of how the questions might be phrased in the exam. They're going to tell you user 1 or user 2 has already done X, Y, and Z. what is the next step. So you need to know what the 7 steps are, and you need to know in what order they need to go, guys. All right, folks, I hope you've learned something today. Hopefully you have. If you have, do me a favor, give the video a like if you did not do that in the beginning of the video. I really appreciate it. If you'd like to know when lesson 5 of the course goes live, obviously maybe consider subscribing, otherwise you might miss it. And then normally I just give a special shout out and a thank you to all the sponsors of this channel. If any of you guys want to sponsor the channel so I can keep making content like this, you can find that information in the video description down below. But just a quick thank you and shout out to those of you clicking on the thanks button below the video if it's available in your country. Thank you to those of you buying me coffee and milkshake. And obviously to the Patreon and the PayPal sponsors of the channel. Here's a list of the Patreon sponsors. Thank you very much, guys. Here is a list of the PayPal sponsors. Thank you very much, guys. And then lastly, guys, we do have a Discord server. I normally mention this at the end of most of the videos. So if you know what Discord is, and if you want to join my server, you're more than welcome to join it. It's a free IT community of people like me and you. Some of them are studying, some of them have written the exams and stuff. So if you've got any questions, or if you want to help anyone else that's got questions, you're more than welcome to go and join this free Discord server, which is called Free IT Training. All right, folks, I will see you in lesson 5 of the CompTIA Network Plus course.